The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. My name is Sarah Brum, and I will be facilitating today's webinar. It is Lean in the Lab, the Model Room. And today we have Craig presenting. He has over 25 years experience in the dental laboratory, and he is a certified dental technologist with RG and AA. And he works here at Whitmix as their technical support manager. Before we get started, I just want to go over a few general housekeeping items. If you have any questions at all, please type them in the questions box, and that is located on the right hand of your screen. Also, if you're having technical difficulties of any sort, you can also type your questions in there as well. This is approved for NBC credit. You do get 1 credit, and we will send you a test at the end of the webinar that you'll take, and you can either fax in or you have the option of taking it online. So without further ado, I introduce Craig.
Good morning, everybody, and thanks for joining us this morning. We're going to talk about some principles that many of you may have heard about and perhaps in some of your laboratories are applying. Some of you may not have heard about them before. And it's going to require just a little bit of a change of thinking in how we generally do work in the model room, or at least how we approach it. So I hope you'll just kind of come along with the ride here and then use the information in your laboratories to just make things better for you. If it works and it sparks a little bit of an idea there for you, then this whole concept of lean, Whitmix has programs on that can come right to your laboratory and help you walk through some of the lean principles that we're going to talk about this morning. All right. Why use a lean approach? Now, through lean, a lab can increase your capacity from 80 to 85% more than what you're doing right now, and even increase an average profitability from 15 to 20%. Now, you look at that in this kind of an economy that we're in, and you think to yourself, how is that possible? Perhaps your individual laboratories are struggling a bit, but it has to do with being able to do things more efficiently. And that's what we want to talk about today. First of all, we need to determine who our customer is. And all of us recognize that we have an external customer, the dentist, and we go about doing things trying to please the dentist. But we also have what's called the internal customer, and that's that other technician that's sitting in the other room, the one that you are providing model work for. You're actually not providing model work for the dentist. You're providing it for another technician who's there at your laboratory. And so we have to consider, when we're talking about the processes that we use, who's our immediate customer and who is it that we need to be able to focus on and produce work for. The model room is really producing work for the next set of folks that are in the lab, which is going to be your waxers. So let's remember that as we go through this process. Now let's talk for just a moment about what lean manufacturing is. There was a book written in 1996 called Lean Thinking. There were 2 authors, Womack and Jones, and basically what they did was they introduced 5 independent lean principles based on the Toyota manufacturing system. They were these 5: value for the customer, value stream analysis, flow, JIT, which is just in time, which they called pull, and then this concept of perfection. So let's go through this for just a minute, and we're going to define what they are. First of all, value for the customer. Now, we have a little equation there. Value equals worth or cost. Now, all of these things are rather subjective, aren't they? Because all of us place value differently in our lives. If I were to pull a junked car into your parking lot and ask each of you to value it, some would say it had great value, and others would say it didn't have any value at all. It depends upon our experience, what we're looking for, all of those kind of subjective sorts of principles. So value is relative. It's an assigned worth or importance. Now, worth is good or important enough to justify getting whatever that particular thing is. In the case of our junked car in the parking lot, it's how much is that thing going to cost me, and is it good enough or important enough to justify the cost of getting it? Now, to some of us, the answer would be no, it's not at all. To others who are maybe into reconstructing things, that cost would be totally justified. So cost is the price paid to acquire or accomplish, sorry about, not of, but or accomplish anything. And so those three things, value, worth, and cost, are going to play into lean manufacturing or lean in your laboratory. The second is value stream analysis. Now there's three kinds of activities in lean that we talk about. One is a value-adding activity. One is a non-value-adding but necessary activity. And then there are non-value-adding activities which are capable of simple elimination. Now, if we think about that inside of our laboratories, there are things that we absolutely have to do. For example, right now, still, even though we do have systems out there that are talking about doing away with models, a model is still a valuable part of our process. And so that's a value-adding activity. Pouring that model would be a value-adding activity. In Crown and Bridge, now this is a nod away from our good folks in orthodontics, all those great little angles that we grind on models to make them look perfect and presentable, it's kind of a non-value-adding activity, and we can probably do away with that. Okay? Then there are non-value-adding activities, in other words, things that people wouldn't necessarily pay for, but are necessary to have there. Some of that would be like multiple stones. Okay, it's not really a value-adding activity, but it's necessary based on what our processes are. So we want to take a look at those types of things and figure out which are the ones that we can simply eliminate that are taking up time and aren't necessary. Okay. Then there's flow. Flow means to proceed smoothly. Okay, and that's time that's wasted. So if you look right now in your model department and you see models sitting around waiting, not moving, not having something done on them, then those are case pens that are sitting there waiting. They're wasting time. You're wasting dollars by having them just sit there. Now that's a new concept because we work in different kinds of principles, generally speaking. So we have to start at a different way of moving work through our laboratory. Now, JIT is just in time. That is the arrival of materials or the next step that's just in time to do it. That's something to move forward, but it's being pulled, not pushed from someone. Okay? So we don't want to be pushing models out of the model room. We want the waxing department to be pulling them out when they're ready. They should be coming out. Now, does that mean we stockpile and wait for them? The answer is no. No. We need to have everything be just in time, which is an organizational change that we need to look at. Okay? Most of us don't do that. If we have larger laboratories, model rooms are cranking out however much they are. At the end of the day, there's a gigantic pile. In the morning, when the waxer walks in, there's a gigantic pile. That's not a really efficient way of working. Now, we seem to think it is. We have this thing built into us that says we get more done when it's waiting there for us. But we really don't, and we don't push it forward or pull it out of the next department and into ours. And we need to work on that. We'll talk about that today. Now, perfection, that's the highest degree of excellence. Everybody knows that. That's the way work should be done each and every time. And we all know that it doesn't get done that way each and every time. But it is something that we should be striving for in our processes. And it is going to be the thing that sets our laboratory apart, that's going to set our model department apart from other model departments or laboratories that are out there. And so we need to look at things that will help us find perfection in what we're doing. All right, those are the 5 principles. Now, there's something in the lean process that we can apply right off the bat, and that's this little target that you're seeing here. We are going to talk about what's called the 6 S's. Now, Womack described 5 S's. Actually, there's been a 6th S that was added, and that's safety, and you'll see how that all works. So let's talk about each of these little pieces individually. The first one is to sort. Now, that simply means to distinguish the things that are needed from the things that are unneeded. If you look in your laboratory, almost every lab has a few of these cups sitting around, especially if you go look in the ceramics department. A lot of times the model department have them too. They're all full of stuff, and we use maybe 5 or 6 of those items on a regular basis. The rest of them just sit there and actually get in the way of us finding the 5 or 6 that we use on a regular basis. And so what we need to do is eliminate the big pile, have the tools necessary that we need right at hand, and the rest should be put away somewhere for the odd occasion when we actually need them, so that they're not in the way of our constant work. Take a look around. I know you'll see these. All right, the next is to straighten. That simply means to keep the needed items in the right place so that you can get right to them. Most of us have them laying around somewhere, but there isn't a single one of us technicians that hasn't gone looking for a lab knife that you were sure was right there. Okay, we all do it because we don't exactly put them down where we need them. If we need them in multiple places in the room, then the better way is to have multiple lab knives and keep them in a specified spot so we know where that is. But let's take a look at another example. Here is a model room from a laboratory, a very good laboratory, produces a fine product. We went in, though, and took a look at lean manufacturing and how things work. Now, what I'm going to do is grab hopefully my cursor arrow is working there for everybody. What I want you to see is, here's where the model started. Then it moved over here, and it had a little work done. Then it moved back over here and had a little more work done. Then it came back over here for another piece of work. Then it moved back clear over here to the other side of the room for another piece of work, then back here, then easily to this spot. Then it came over here on this bench, came down here, got a little bit of QC work, and finally came out the door. But you see all this back and forthing? What a lot of waste of time. Wouldn't it be better if the flow was easy across here? And what needed to be done was that these individual pieces of machinery that were being used needed to be rearranged in an order so that the case pan moved from one place smoothly to another and then out the door so that we didn't waste our time. So I'd make a challenge to just the model room manager just to sit sometime, if you would, take a piece of paper and track where an individual case pan moves. Every time it moves somewhere, write down where it went and take a look at what you wind up with. Now these are generally called spaghetti charts because in the end it looks like you've got a big pile of spaghetti running around your room and you're wasting time. You're wasting a lot of man hours in that process. All right, the next one is to shine. That means you need to keep the workplace neat and clean. Now we've seen model rooms that are beautiful, neat, and clean, and we've seen model rooms that look a little bit like a whole gang of kindergartners have been in there for a while throwing stuff around. They're dirty, they're messy, there's plaster everywhere. We've all seen them. Some of them look maybe a bit like this particular laboratory that I walked into to manage many years ago. It's a mess. It didn't stay that way for too long, but it can't stay that way. If you look, we've got open bins, we've got dust and garbage all over counters. It's just everywhere. It's a mess. You cannot produce perfection if you're working in this kind of an environment. Now, what does that mean to your laboratory owners? It means that you're going to have to put some dollars in here and clean the place up. It means that you're going to have some time allotted for your technicians to clean every single day to make sure things are squared away and therefore more efficient to work in. All right, the next one is safety. Now we all know that regulatory standards are out there. We're having to do more and more and more of regulatory standards. They should be documented, they should be followed, and you should have a system in place in your laboratory and even in your model room for how things work. Whatever that system happens to be, but it should be a system and it should be documented where everybody can go to it, find it, know what it is. Everyone should be trained on your system. And that's going to take a little bit of time also. All right, now the next one is to standardize. That's one of the things that we need to do. It's interesting to do in our particular industry because we realize that although we do approximately the same steps, each and every model that we're creating is different than the previous model. It may have a few different steps based on what's necessary to be done. But we need to be able to standardize our process as much as we possibly can. Okay? And that would include the materials that we use in our process. We want to do it the same every time. Now there's a couple of really good reasons for that. First of all, you produce a consistent product. We know in some of the polls that have been taken through some of our industry magazines that that's one of the things that the doctors like, which is consistency. And so we need to produce that consistent product. We do so by using consistent materials, consistent methods, consistent processes. All right, the next thing is to sustain. That means we got to keep doing it over time. We can't just do it for a little while, then slip away, and that's what most of us do. We kind of get in this process. We get phone calls all the time from folks that are having problems with materials, and one of the first things they say to us is, I've been doing this for, and then fill in the amount of years, and it's always more than 10, okay? I've been doing this for 15 years. I always do it the same. Well, we know that that's just not possible. So those of you who believe that you do it the same way, just not possible. You always drift a little ways away, and it's good to review and go back to make sure that you're actually doing exactly what you're supposed to be doing. And that will help you produce a consistent and a more perfect product. So you want to sustain all of these things that you have done. That includes clean, that includes materials, that includes processes. And continue to do that process as you move forward, unless you see a good place to change the process. And that's always a viable kind of a response to things that come your way. Now that creates this entire target to shoot at, and we hope that you're getting bullseye every time. And this may be a lot of work for some of you to begin. But it's a good thing to look at. Just generally look at your model room and say, what can I do here to sort, straighten, shine, to increase our safety, standardize everything we're doing, and then sustain so that we get a consistent product going out not only to our external dentist customer, but also to our internal customer, the next one in line, which is going to be our waxers. Okay? All right, now where do we start? Well, first of all, you got to learn something new. You can't say, well, I've done it this way for 20 years, or I've done it this way for 30 years, and continue to do it. This is something new, and it's going to mess with your mind just a little bit, but that's okay. Just look at it and see if it's applicable in your situation. Okay? It's not about what the model and die room can get done in one day. It's about what the lab gets done in a day. And that's what we're going to talk about in the next little while. Now, model and die folks often kind of focus on their own room, and they get going and say, if I do X units a day, then I'm in great shape. And they look at the entire day to get them done. We're going to talk about doing them a little faster and a little differently than normal. This is pretty much a consistent looking dental laboratory right here. If you look, right, we've got all these models all lined up. We're just going to pour 25 or 30 of them all at a whack. And we're going to talk about doing that just a little differently, but accomplishing the same amount of work in a day. All right, now PTC's John Ness, who we lost this last year, said that you should work, those of you who have been through PTC training, you'll know this, said you should work in groups of 5 to 8. So that's what we're going to take a look at in the model department, not the previous slide, which showed 25 and 30 models being ported once or bases being ported once. We're going to talk about this idea of working in smaller groups. Now, batch size changes how we do things, and this is kind of a chart. It's a little hard to understand sometimes, but if we take a look at it, we want to be able to increase our flow. We also want this ability to catch systemic quality issues early on. In other words, if we've got a model problem, we don't want to find out about it when we're trying to add contact in the ceramic department. That's too late and puts us under too much pressure. We want to know that we have issues right at the front of things. So if we're not reviewing things until after we've done, in this case, 30, then we have problems here, okay? The first case doesn't get finished till out here somewhere around this time frame. What we want to do, if we shorten that to 15, you'll notice that the first cases get finished in your lab a whole lot earlier. See that? And if we drop it even smaller and do it in groups of 5, we still are finishing the first cases. We're producing just as many in a day, but we're finishing it faster and it's moving on to other departments That's the kind of thing that we want to deal with. And we're going to talk about using smaller batch sizes. Now, this is probably the #1 thing that model and die departments rebel against. They just can't conceive of doing smaller batches and getting as much work done. But it's entirely possible, and we've seen labs turn themselves right around on the dime, produce just as much work without having as many mistakes and without having as much problem as they do by using large batch size. All right, let's take a look. Here we go, and we'll get going. Now, our goal here is that we want to produce model and die work completed on 5 cases, and we want to have them completed and out the door to the waxer in 1 hour. 1 hour. Now, some of you are going to say, I can't do it, but we really can. And it's going to take a few things. Okay? These are the things you're going to need. You're going to need automated dispensing and mixing equipment. You're going to need some kind of a fast cycle type 4 die stone, a fast cycle type 4 base stone. You're going to need your pinning machine, a die pin system, an articulation system, a die trim and spacer system, and you're going to need a little bit of courage to try and do something differently, since a lot of you have been locked in for many years. All right, now here's the machines we recommend as far as those automated machines. And of course, we're going to recommend Whitmix machines because they are terrific. One is the AquaSpense, which is going to allow you to dispense liquids and weigh your powders correctly. That means you're not over at the sink guessing, but you're actually weighing them to exacting manufacturer standards. The other is the VPM2, which is a hands-free mixing unit. Now, we love our old unit. We still produce lots of them. They're still referred to as the whip mixer out there, but they require you to stand there. And standing there, as you'll recall, is actually wasting time if you don't need to. If you're mixing something for, let's say, 2 minutes, how many times do you mix during a day? Add that all up. That's a lot of standing around time that you could get something else done. So those are the machines. Now, the gypsums that we're recommending right now are a little bit different than what you're normally used to. We're recommending lean rock, comes in 2. This is the die stone. This comes in 2 different expansions, 0.08 and 0.20. And we're recommending Flowstone Fast Set, which is a 0.08 expansion and is a fluid base stone, which means you're going to need to use some kind of a basing tray. All right? Now, why won't my regular stone work? The answer, won't it work? The answer is no, it won't work. And the reason it won't is that normal stones take a minimum of 35 to 45 minutes to reach final set, and that's too long. Also, though, they might take as much as up to 2 hours to reach their final expansion, which means that before you go chopping things apart, you better have stone that's fully expanded or close to it. You need something that's faster expanding than that. That's a very important part of this so that later on down the line things fit. Okay? Now, you're going to use a pinning machine. We're recommending, and we'll use here in this demonstration, the mainstay pin system. This pin system has worked really well for a lot of laboratories. If you're still using the old brass 2 Dowel pins, you may very well consider moving on to a new system that's going to help you be a little more accurate than they are. Mainstay drills are matched to these the heads on these pins so that everything works and fits the way that it should. All right, we're also going to recommend our PDQ Die Prep Kit, which is going to give you your spacer and your thinner and your die lube and all that kind of necessary stuff that you need. We are going to start with 5 impressions, and over here on the right-hand side, you'll notice we're going to start the clock. This is an arbitrary clock. It's going to begin at 9. It's a little different time zone right now than where we are, but you'll notice how it works as we go along. All right, we're going to start the mix process, and the way to do this, instead of running to the sink, dumping some powder, trying to guess, thinking you're fast, we're actually going to take the bowl, we're going to place it on the machine, and we're going to push TARE. Okay, that's going to zero out the bowl. Then we're just going to put the approximate amount of powder needed for 5 models, which is somewhere around 400 grams or a little bit more. You just don't need gobs and gobs, okay? You wind up wasting time grinding all of that excess stone off the backsides of models. Those of you who've been in the model department for a long time that have models sent to you by dental assistants that have poured them have complained numerous times, I know, about how much is on the backside of those models and how much has to be ground off. You're doing a lot of time grinding, and you just don't need to do that. So let's not do it in the laboratory. Let's get the right amount. All right. It's going to be approximately that much. You throw it in the bowl. You hit the start button. The machine is going to deliver the right amount of water for however much is in that bowl. Now, you can't do that at the sink guessing. You can do it using a graduated cylinder if that's the system that you're using, but it's going to take you more time. We've all struggled with that before, and many have just given up and said that's close enough. We don't want to do that. We want to be accurate. If we're going to do the perfection part of 6S, we're going to need to do, and the consistent part, we're going to need to have things consistent, and these machines help you get there. All right? You hit the start button, the water goes in. Now, you're going to transfer that after the water has been in there. You can transfer it over to that hands-free mixer, and you're going to put it up there and hit the start button. It's going to suck vacuum and start mixing, and you've got time now to do something else while it's mixing. Now, once that material has mixed, you're going to have to treat this just a little differently than you do normal stones. We get a lot of comment here about stones, and every technician has something else that they want their stone to do. They keep trying to find a stone that will match them, rather than changing their process to match the stone. In this case, using this material, you're going to have to change your process. It will not behave the way you want it to. We've had folks that say it sets up too fast, so I added more water. Well, that will slow down the set, but it also makes it a weaker stone. And it also changes some of the other properties, so you don't want to do that. You need to change your method. And the best way to do this, oh, I should tell you too, we've also had people call us and say, well, they don't like the stone, it's too thin and it won't stack. Well, stackability is a nice thing if you're trying to put a big gob of stuff on the backside of your model. We don't want to do that in the first place. But we also know that this stone is a little thinner, and it is going to move very fast into its initial set. It's going to do that within 5 minutes. So if you're going to pour 5 models, what you want to do is pour the tooth surfaces of the model first for all 5 impressions. Not one, and then try and stack up a base. Don't do that. You move on, pour the tooth surface, move on to the next one, tooth surface, move on to the next one. Then you come back and add the base to the impression. Now, when you do that, the stone is not set, but it's getting closer. You've used up a portion of that 5-minute time, and the stone, therefore, will start to stack better, and you can put a base on. Now, you're not going to drag a giant base up because we're not going to waste that time grinding. But this is the process that you're going to do. It's a little different than what you're used to. You're used to pouring one totally, pouring one totally, pouring one totally. We're going to change that. All right, you've finished your 5 pours, you've finished all the mixing, you've finished all the measuring, and you've done that in about 5 minutes, which is a whole lot faster than you generally do things. You've got 5 models that are waiting here now, and they're going through their setting process. Now, don't waste time. You have 10 minutes before that lean rock is ready to pull out of the impressions. And that's right. If you added that quickly, that's 15 minutes from the point where you began your mix. Now, why can't you do that with your regular stone? Well, because you're going to be double that time before you can even begin to think about pulling your impression from the model. In this case, you're going to be able to pull lean rock in 15 minutes from the point where you mixed it. Okay, now, if you have opposing models, separate opposing models, now's a good time to pour them up. Okay, it's a little different if you're working with quadrants. You're going to have to wait just a little bit more until that quad is the initial pour has reached its set before you can pour the next one. But if you have separate models, now's a good time to pour them up. Or you can start working on the next batch of 5 cases. Pull another 5, get them poured. Now you're going to say, why didn't I do them all at once, 10 of them? Well, because you don't have time. You're going to run out of time. If you can pour 10 with this material, then you are lickety-split fast. But in general, you will run out of time. You'll be unable to do that. Okay, so work with 5. Work with 5. Now, you're at the 15-minute mark, and you're going to pull the cast from your impressions. Okay, you're going to check for good things like bubbles and other such problems, irregular pores, anything else that you've missed when you reviewed your impressions in the first place. If you've got something that went wrong, now you pour it, and you're only 15 minutes in, and you're pouring that second pour. You're not 35 and 45 and an hour in before you notice that you need to pour a second pour. So you're getting faster as you go. Now you're going to take and you're going to trim all 5 models, because they're all 5 ready to go. Get them trimmed down. There won't be as much time involved trimming because you don't have as big a base on the back side of them in the first place. Then you're going to remove the pallets. There won't be as much time doing that because your models aren't as thick as you began with. Use whatever method you normally use. If you've got routers, that's great. If you're working on lathes, that's fine. Whatever your system happens to be, go ahead and do that. We should be right about at the 20-minute mark at this point in time with our first 5 models. All right, now we're going to go ahead and we're going to drill and glue dowel pins into place. And you're going to say, aren't the models wet? And the answer is they're a little damp at this point in time. It's not going to hurt your super glue at all. In fact, it'll actually help it set off the reaction that you need to lock those into place. You're going to then place your sleeves and your booties if you're using our system, or another system if you're using that. We, of course, would prefer that you try this one out, and samples are available just by calling in. Okay? And you're going to want to paint on your separator at this point also. All right, you're about 25 minutes after, or 25 minutes into the process with these first 5 models at this point in time. Okay? Now remember, that's 25 minutes. You have everything poured, ground, trimmed, die pinned, and ready to base. Your other model stones you've not yet pulled. If you were using another model stone, you would not yet have pulled it from its impression. So you can see how far ahead you're getting on these 5 cases. Now, you're going to repeat that weighing mixing step for the Flowstone base stone. Now, the thing that makes this easy is all you're going to do is in your Aquaspense, you're going to change to a different program that you've already pre-programmed with the appropriate weights and measurements for Flowstone. You're going to hit TARE, zero out your bowl, throw in the appropriate amount of material for 5 units in their bases. Hit start, the water's going to go in. You're going to move that over to your VPM2 and hit mix again, and it will get going. In those 5 minutes, you'll be able then to take and to organize what you're going to do into your bases. Okay? Stand your models up. Now, with quadrants, we recognize they have a tendency to fall over. You can improve that standing up in your base simply by staggering your dowel pins just a little bit. Or you can invent a little device. You guys are all creative. That'll hold a quadrant steady for you inside of a base. Now we're choosing at this point to use these disposable bases. We know that many of you have other bases for different articulation systems, but basically it's going to work the same. You're going to then take the Flowstone and simply pour the Flowstone into your base form. That will flow up the sides of your pins, and it will suck up. Basically, it's a kind of like a capillary response onto the base of your model, and you're going to go right down the line in 405. It's going to be very fast. Now, what does that take out of play? Well, a lot of you are vibrating. A lot of you are pouring bases and then trying to shove your pins down into the stone and hope that it works with a little fancy jiggling procedure that you developed over the years. Some of you are pounding your bases, you're doing all kinds of things trying to get things to vibrate. Some of you are using a lot of vibration. None of that is necessary with Flowstone. You simply pour it in there and it's done. All right, now some tips. I worked in a laboratory. We had extra empty base formers on hand, and if you had extra Flowstone or base material, you poured them into those bases. And then later you used those bases for your opposing, and you simply superglued the trimmed opposing onto the already poured base. It was very fast. You didn't have to pin anything. You didn't have to wait for things to dry. You were ready to go. So you might want to think about doing that as an opposing rather than trying to pour a base and set the opposing. But now is the time to base the opposings for the 5 cases you're currently working on while you're waiting for all of that to dry, okay, for your original pinned models for that base to also dry. It's going to set up approximately the same way, the same speed that if you use the FS, Flowstone FS, that your die stone did, which is important. We need that to also reach a certain point of expansion before we cut apart our dies. That's one of the things that the model and die department forgets about. They pour their models, they wait a period of time to hope that the expansion's right. They pour a base on there, and then as soon as the base is hard enough, they go ahead and cut their dies apart. But the base hasn't completed its expansion yet. And then you have problems. Generally, they show up as contact problems or fit problems in long span bridges because you've not waited for the base to fully expand. And remember what we talked about in that gypsum property of whatever you're using might be as much as 24 hours later by the time that that base gets fully expanded. So you've got a time issue that you may want to shorten up by use of a different product. Some of you are doing other things. You're playing chemist or cooking, as we usually call it. By throwing a little of this and a dab of that and a pinch of that, you come up with your own base material. Usually it's wrapped around cost because you're trying to save some money. But what happens there is you mix up all of these different stones. Maybe you take some type 3 yellow stone material and you mix it up with some plaster just to extend it. But now you've changed all the properties and you change how it works, change its setting time, do all that stuff. Is it working for you currently? Maybe it is. But if it is, it's because you've changed something else in your process to accommodate that change. It's a mixed mess. And what you need to do is get back to something that is easily definable. When you do that, it'll reduce your phone calls into Whitmix to ask us what's wrong with our material. There's nothing wrong with the material. It's how it's being used. We need to take a look at those kinds of things. All right, now, you've got that taken care of. You're about a half an hour into this process with the first 5 models, and you've got some models following behind them also. You need to keep yourself moving. You have about 10 minutes to get your articulators assembled and ready, depending upon the articulator you're using. If you started the next batch of 5, you want to do the next step, whatever that happens to be. If you have time, then you can do one of the first 3 S's in there. You can sort, you can set in order, maybe you can shine a little bit of cleaning up in the model and die department. Let's not let that stay all day long. You know, it takes a quick wipe down and you're going to reduce half of the dust and the powder and the garbage. Maybe clean a machine. You wouldn't believe how the model trimmers look when they come back for repairs. And some of the problems that they have that could have been addressed simply by keeping the machines clean. You've got a little time to do that now. Don't let your model room look like the rest of the model rooms that are out there. Or maybe like that first model room that I showed you a picture of. Let's get them cleaned up and looking beautiful and professional. All right, now you're going to pull the base from the formers and you're going to articulate. Now this is going to be faster or slower depending upon the articulation system you're using, but you can use any of them from a large frame articulator, a semi-adjustable, right on down to a plastic glue-on, whatever the system is that you're using. Now's the time to take care of that. And we're a little better than 45 minutes into this process. At this point now, after you've articulated, which is going to take you a few minutes, you're safe to saw out your dies. Now, lean rock in this time frame has reached about 82% of its total, in this case, of 0.08 expansion. Now, what does that mean to you? Well, the 0.08 that is reported from WhipMix is reported by the use of 100 grams of material poured into a 100 millimeter long test platform. So if it says that it expands 0.08, what that means to you is that it expands 0.08 millimeters in a 100 millimeter test platform using about 100 grams of stone. That's about a model, okay, about 100 grams. And so you're going to get linear movement of approximately 0.08%. At an hour, you've reached 82 or so percent of that 0.08, which leaves you not a lot of movement left. So if you cut your die apart using this particular lean rock material, you're going to have very, very, very little linear movement of that stone, which means you're going to have fits that are accurate even though you're doing it within an hour. Now, a little bit of a tip. If you lift up your pin model, you may have seen that in that last slide picture. Lift your pin model totally. If you were using the machine, they should all lift up parallel. Rest it on some cotton rolls or wooden dowel or whatever you want to invent there while you're sawing out. It'll get you a cleaner looking base. You'll have less saw cuts into that base, therefore less places to trap wax particles maybe later, or investment, or whatever it is that you're goofing around with as you go later on in the process. You want this to be as clean and professional and perfect looking as you possibly can. Now, using this system, you're going to now remove the booties from the bases. And doing that, you're going to have a good clean access hole to an undisturbed pin bottom. If you're still using a drill to drill out those things, you're just creating problems. You really are. Most of us are not good enough to miss hitting the bottom of a pin. If you're pulling that through stone bases, then you're tearing up your stone base each time that pin goes in and out. If you're doing that with a sleeve, the same thing with a sleeve, and you're just building in inaccuracy in your model and die department. So use these booties. They're great. They're easy. They don't take a lot of time to assemble, and you get a real nice clean product. You're able to pop your pins free and clean. Do all 5 of them. Now, trim all 5 of your dies, and remember, you're just trimming 5 dies. There's many, many laboratories I've been into where I walk in, you've got a die trimmer sitting there, and right next to him is a cart full of about 50 cases. And he's trying to catch up trimming dies, or she is trying to catch up trimming those dies. And meanwhile, all those cases are just sitting there doing nothing. We're just going to do 5 and get them moved to the next step. Okay? You've got about 4 or 5 minutes left in our hour, and so use magnification. Another tip, nope, your eyes are not as good. I don't care how young you are. And you might be able to see great right now, but remember, your doctor clients are looking through at least 10x at your work. And that means that if you're not seeing it at that level, they're going to see things you don't see. So you die trimmers, make sure you're using magnification, get down in there and see what is actually going on. Find the mistake early on so that you don't have to correct the mistake later on. Now, at this point, you're going to paint on the die hardener and you're going to paint on the spacer. Now, one more little tip here. Paint the die hardener just above and below the margin, not over the entire die. If you're having problems with your spacer peeling when they're steaming them or other processes, probably it's because you've tried to die harden everything and then you painted over the top, and that spacer did not have anywhere it could hang on tightly to, okay, like some raw stone. If you'll stop doing that, simply paint it around the die margin area, which is where you really need it, and leave a little space that paint or die spacer paint will adhere better to your dies. You'll have a better product. All right, now you're going to reassemble the articulator at this point, and you're going to take those 5 cases out to the waxer. You've been able to accomplish 5 model and die cases in an hour. Now let's take a look at what that means to your laboratory. Okay, 5 in an hour. Here's a little statistical information if you can follow through with it. This is the first single 8-hour day that you start this process. You're going to have 5 cases done in an hour. That means in an 8-hour day, you're going to have 40 cases delivered to the waxers. Now, in a small laboratory, 40 cases is a lot of cases. In a big lab, maybe not so many. But remember, this is 40 cases for one model and die technician, doing 5 in an hour. Okay? Pretty efficient stuff when you think about it. You're going to do 5 cases per hour. That means that you're going to have 35 cases delivered to the investor by the waxer. The reason there's only 35 is because at the end of the day, you still have an hour's time left. It's a little bit of a lapse time. And remember, this is the first day. You're going to use rapid burnout techniques for your investing, and that'll be 30 cases that are cast and cleaned. You're going to have 5 cases per hour delivered to, that's 25 cases to the metal finishing department. And you're going to wind up with 10 cases of ceramics done at the day's end. You'll have 5 cases that are bowled out. Now, that doesn't sound like much on that first day, but don't worry about it because we're changing a process right here. It equals about $500 at an average of $100 per unit single case. All right? But let's look what happens on the second day. On the second day, you're going to need at least 2 ceramists. Okay? You're going to have 40 cases completed at the end of the day by the model and die department, and by the waxing department, and by the metal casting and finishing departments, and by the ceramics department. So the 2 ceramists has given them 20 units a day to do. Hopefully they're that quick. If not, you might need 3 ceramists to cover that piece of a bite. Now, if we look at that number and say the average is 100 units per, or $100 per single unit, then you're going to bill $4,000 that day. That's $20,000 a week. That's $80,000 a month. That's a $960,000 year gross billing. And I would bet that a small laboratory like yours, many that are out there, are not billing $960,000 a year, which means that you're probably not doing 40 cases a day, which means that you're not really doing what your total possibility is for your laboratory with the size that you have. And you think about that for a minute. What is it that you are capable of doing versus what you actually are doing? A lot of what the work is that we put in that takes so much time and wears us out is really work we don't need to do. If we could get a little more efficient, if we could become a little faster, work a little bit smarter at the things that we do, then this 960 is all about finding the work to do, not about not having time to do that kind of work. All right, now there's some reading out there that you can do if you're really interested in this concept of lean, getting things done right, learning to see. This is Shook, who's doing it right now. 5S, that's a good one to talk about. Lean thinking is a great one by Womack and Jones again. If you really want to go back to one of the original lean guys, Henry Ford wrote a book called Today and Tomorrow and put together that whole Ford manufacturing system. That was early on lean thinking. And everybody knows this comment about Ford. How did he make things work so well and so easily? Well, you could have any color car you wanted as long as it was, and everybody should be saying black, because that's how he did it. Leaned out, simplified. It was easy. It didn't have to change paint. Lean simplified is another one. Pascal Dennis, the Toyota production system. You can read that if you want. All I need to know about manufacturing, I learned in Joe's Garage, which is an interesting comment there. Now, if you're really interested in lean manufacturing, we have some upcoming events, and then you can always reach Bob Long at the Whitmix Corporation, who is a lean guru and is capable of coming into your laboratory really taking a hard look at what you're doing and how and suggesting how you can implement lean manufacturing in your system. If you'd like to talk more about some of the lean products or the lean machinery that we have here at GYPSUMS, please don't hesitate to give us a call at the 800 number for GYPSUMS, or to give us an email or look on our website for some of those products that are out there. If you want to talk more about the gypsum products and how they behave, we've got a couple of good technicians that are here that are more than happy to talk to you about those things. Okay, now we're at that spot where there's questions. If you have any questions, go ahead and jot them in, and we'll have our moderators help us out.
Well, we did have a few questions come in. Craig, our first one is, what about re-disinfect after you trim a doctor's poured model?
That's going to take you just a little bit of time, and you're going to want to take a look at the product that you're using to re-disinfect, and we know that's going to be the case. That's going to change about how you do this, and if the doctor poured the model, you're not using the same stone, so you've got a time differential there. You need to find out what stone the doctor is using so that you can apply the time differential. And then when you re-disinfect, you want to be careful that you're also cleaning your models after you've disinfected. Part of the problem that a lot of labs have is that the doctor disinfected, then you re-disinfect. Now we have a lot of disinfection material that's laying all over there, and it can create problems later on down the line with other products you use. So one of the easy ways to do that is simply to use a Dawn dishwashing liquid. I know it sounds strange, but you know those advertisements about Dawn are kind of true. Generally about a tablespoon of Dawn in a liter of water, and a nice soft brush. If you're gutsy enough to go over, you can swipe one from the ceramics department, and then just scrub the model off and rinse it under the sink. Make sure you get all the soaps and disinfectants off of there before you continue your process. I hope that answered the question.
Okay, another question is, how long does it take Flowstone to reach full expansion?
Basically the same thing. It's going to reach right up around 80+% within that first hour. And so if you're using the 0.08 material, which is what it is, it's a low expansion stone, which is what you should be using for your bases. If you're using, I know there's some talk out there about using matching expansions, so if you have a 0.20 die stone, you should use a 0.20 base stone. And in my mind, I don't see how that works. If you think about it, your 0.20 die stone has reached its expansion at whatever point you're putting fixed pins into a base, and those pins are fixed in position. They're not moving anymore. And now you're putting a 0.20 expansion on them. Doesn't make sense. You want to use a small expansion, as small as you can get, base stone. Now remember that most of us are using base stones that are type 3 stones that are up somewhere around 0.12 to 0.18 expansion. And so there's a differential there that you've got to take a look at. The Flowstone FS is going to reach that same expansion within the hour. So it's going to be shortly after you've cut apart your dies.
Going back to the Flowstone FS, what is the set time to pull the base from the mold?
The set time to pull the base from the mold is 15 minutes again.
And how do you pour a base of an opposing model with Flowstone without the model sinking?
Well, you can't unless you're tricky, which means that you have to watch for the initial set of the Flowstone, which is up at around 7 minutes, before you drop it on there. That's why the suggestion to pour extra bases ahead of time and then just simply super glue them on. Otherwise, you've got to rig up some kind of a paraphernalia to hold them in place, and that's kind of crazy. So you've got to just, if you're going to do that freehand, you're going to have to watch for that spot just before initial set where you can snug those opposings into that Flowstone base.
Okay, we have a question for some of the larger labs that might be listening in. What about 400 cases a day? Do you think the same thinking works, or should they just increase the batch sizes?
You can increase your batch size, but you want to watch how you're increasing your batch size. Even though you're doing 400 cases a day, remember you've broken those 400 cases into several technicians that are in that department. So break it down and see how many cases the individual technician has to be producing in a day, and then break that down into a batch size and try and keep it moving. The point is not to do 400 cases in a day and at the end of the day ship 400 cases to the wax department. It's during the day you're shipping out nearly 400 cases to the wax department. You just have a few left over at the end of the day that you've just completed when you go home and the wax department goes home. But there shouldn't be a big lump of them dumped on the wax department. They need to be moving continually. And the closer you get to continual movement, the more lean you are, the better manufacturing process you are, and the quicker they go out the door. Model and die is only the first place to begin. You got to get lean in the wax department, lean in the casting department, especially you got to get lean in the ceramics department, and then move it out the door. The faster you move that unit, that case pan through the laboratory, the quicker that thing is billed out. And that's actually what we're after, isn't it? We could keep them all day long, and all week long, all month long if we wanted to, but we're not making money by having stuff just sitting in the laboratory. So take a look, even if you're a 400 units a day or cases a day, take a look at how that breaks down and what each individual technician needs to be moving. Now that might mean that you're going to need to reconfigure your model and die department a little so that each individual technician can move his product faster. It's going to take some thinking, but you'll be able to get through it, I'm sure.
Okay, we have another question. We currently use die-keen ivory for our dies and our bases. Do you see any problems with that?
Well, the biggest problem I see with die-keen, and granted, you know, we don't produce die-keen, but the die-keens, even if you look at it, its expansion varies. It's never the same. From 0.18 to, you know, somewhere over 2%. It's a larger expanding stone. You're going to have to check very carefully with the manufacturer and see what all the parameters are. Where is it? Where is it expansion going to set up, and where is it going to go? You're not going to be able to use it rapidly. It's going to have to set and wait. You're going to have to spend that time frame. So if you want to continue to use die-keen, that's fine. If what you need is the expansion, which is up around 0.20, then you can use lean rock 0.20, which will give you approximately the same expansion more consistently, and you'll still have that ability to do things quicker. And the lean rock does come in an ivory color.
Okay, we still have a lot of questions out here, so we're actually going to hang on past the hour. So it would be great if you could stay on with us, but if not, we completely understand you have to get back to your work, and we appreciate you attending. Just real quick, this webinar is recorded and will be posted on our website in about 48 hours. So if you want to review anything that we talked about today or see what questions you've missed, you can certainly do so by visiting witnix.com. Our next question is, if we use Artimax systems, do we wait to thaw out and trim dies to let the lean rock reach 82% of its expansion?
Yes, you're still going to want to do that. Even if you're using the Artimax system, as soon as you saw the dies out, even though they go back into a retained position, the stone is still moving. And so you're going to have some contractual issues between one die and another die. In fact, if you look at it, Artimax has two different types of trays, right? They have the walled and the wall-less, and most people are going to the wall-less. The reason is because the expansion used to would begin, customers would take out the die and they'd be working on it, and then they couldn't get the dies back into the walled tray. And why couldn't they get them? Because the stone was expanding during that time. So what I would do is I would wait a little bit of time. If you're only working 5 at a whack, remember it's still about pushing 5 to the model and die department, pushing 5 to the model and die. If you're faster than that, I'd be surprised simply because you should be waiting for your gypsum material to be setting up, and that's going to take you longer than the time frames that we were talking about in the first place. If you're sawing them out early, that might be part of the reason why you occasionally have problems, especially in the bridge areas, using that system. It's not the Artimax articulator that's having an issue. It's that the gypsum is not finished doing what it needs to do by the time you get to chopping things apart.
All right, our next question, can you explain the different expansion options? Is there one better for long spans or single unit cases?
Well, expansions are interesting. You don't want to have large expansion necessarily for long span bridges. The problem is, as you well know, if we have any of folks out there, maybe if you're just working in the model and die department, you don't see this other than when the other departments come back and hammer you for something you did wrong with their models. But there's a difference between the expansion that takes place interior on the die itself and how the coping now fits on the die versus what takes place over the entire mass of material and has a tendency to create a larger model down the road so that you can't get a casting to fit back on. We see a lot of that taking place not in the dies themselves and the models, but actually in the investing process. That's where a lot of that problem takes place. And in fact, Ed Harms over at Palladium, who just passed away here just a few weeks ago, unfortunately, and we give a lot of respect to Ed as a technician, came up with a little process on the not model and die side. As long as you're watching what you're doing and doing things consistently, but on the investing side. And if you'd like to learn a little bit about that, please give us a holler here if you'd like, and either Will Devine, who's one of our technicians up here, or I will go through that process with you on investing. Or if you call over and you talk to Ed Jr. at Palladium, they can walk you through it too. It's a simple process that has to do with expansions in the investment material, not on the die stone. Now, the other problem, though, is that if you in the model and die department aren't controlling the expansion between your base stone and your die stone so that you're arbitrarily moving dies apart, then you've got a problem also. Now, that one's going to show up as everything fit in the lab, but it didn't fit in the mouth. The other piece of that, of course, you've got to keep in mind is what did the doctor do with temporaries in his bridge, okay? Because the mouth is not a static place. It's mobile, and if the doctor's not controlling the mobility of that patient's tooth or teeth, then whatever you build in the laboratory in a fixed position is not going to fit. So there's many factors involved there. You kind of have to walk through it all to find out which one is actually the cause of your problem.
Does die trimming the model within 1 hour gum up the burr?
This material is actually pretty doggone close to as hard as it's going to get, and it's not. I haven't seen it gum up the burr. We use a crosscut burr, and haven't had that problem. If you get a little bit gummy result, then the chances are real good. We need to go back and look at our ratios and make sure that they're correct. But you should not have a problem. Those labs that are using this lean process, we're not getting reports of that. Now, I can see that happening with standard die stones because they have not only have they not reached their expansion, but for the most part, their set time, their total set time, is up around an hour plus anyway. What you're pulling them out at 30 minutes is actually closer to their initial set, which is a reported time frame, not really when they've gone and reached their total hardness.
What about when you're doing quality models? In my case, I sand the models for a cleaner and neater look. How would that affect the 5 models in 1 hour outlook?
Well, I think you can still sand them down. You're just going to have to do it closer to the end. I'd put that as an end process even. I don't see a problem with doing that other than you're adding some time frame. So if it's a few more minutes, then your standard isn't going to be within an hour. Maybe your standard coming out of your model and die department is an hour and 20 minutes or an hour and 15 minutes. But whatever it is, it's a whole lot better than having it all sit there for an entire day.
Okay, and we're on our last question. We are currently using a Redford 5B pin with metal and plastic sleeves. Do you see any problems with this, with dies not feeding all the way down using the two different sleeves?
No, not necessarily. Now, I will tell you this, even though we're recommending a plastic sleeve here, one of the things that I did not bring up that we should bring up is that plastic sleeves are going to respond a little differently than the metal sleeves will. Metal sleeves are in a fixed position. They don't have as much drag usually on the die pin as it goes in, the actual die pin. And they will seat within a small distance, a small parameter. Whereas generally the plastic sleeves have a longer distance of seating depending upon what's referred to as the diopter of the plastic itself. That's its flexibility. And so you're going to feel a difference in there, but it shouldn't give you a difference in seating unless one of the things that we've noted is that if you're being overly aggressive with a steamer, after you have completed your bases and you're steaming through those holes and heating the plastic up, you could be deforming it a little bit, and that's going to create a problem. So just be a little more cautious with that steamer. I don't see a problem in some kind of disconnect between two different pin systems out there. Honestly, I don't. I think you'll be just fine.
All right. Well, thank you for all your questions. I just kind of want to mention a few closing remarks. Upcoming WITMIX events, on October 7th through the 8th, we will be holding a Lean Symposium. For those of you who are interested in possibly creating a Lean transformation in your office or laboratory, that'll be some great information for you to start. For more information, go to our website, witmix.com, or give us a call, and we'd be happy to discuss it with you. There's going to be a lot of great speakers and a lot of information about lean processes and how you can sustain it in your lab. We'll also be doing another webinar related to lean processes in December as well, which is going to help you sustain your process. And once again, before we go, this course is approved for 1 NVC credit. You will receive an email in about 24 hours with information on how to obtain that credit. So if you have any questions, you can email us at webinar@witmix.com. But again, I think that closes today's webinar, and I appreciate everybody for staying on the line, and we look forward to seeing you at other events. Thanks, everybody.